My name is Curtis Van Schaff, and I'm an assistant professor at Louisiana Tech. This presentation is about a project entitled Probabilistic Estimates of Cost for Treating Southern Pine Beetle Infestations by Cut and Leaf Suppression Measures During an Outbreak. Eric McConnell from Mississippi State, Michael Crosby and Jason Holderith, also from Louisiana Tech, Ann Jim Meeker, Chris Steiner, Brian Strom, and Wood Johnson from the USDA Forest Service Forest Health Protection in Pineville, Louisiana, are also part of this project.
The Bienville National Forest occupies 178,000 acres in central Mississippi and experienced an outbreak of southern pine beetle beginning in 2015. In 2017, cut and leaf treatments were applied to many actively enlarging infestations within the BNF in an attempt to mitigate the spread of and losses due to SPB. Contractors treated 330 different spots on the BNF, the Bienville National Forest, out of a total of 1,660 recorded SPB spots, or approximately 20% of all spots, at an average cost of $645 per acre. The treated locations on the BNF during 2017 thus provide prior information to leverage into a means of estimating infestation spot sizes and associated cost with future outbreaks. Spot size acreage data from 2017 cut and leaf treatments in the BNF were not found to be normally distributed. Thus, a variety of approaches were examined to model the observed spot size behavior. The goal of this project is to provide a probabilistic assessment of treatment areas and associated costs. This will provide resource managers a tool to assess potential treatment costs during an infestation of SPB. Treatment data from the BNF were obtained from Forest Service records for spot sizes per treatment. Ultimately, a two-parameter Weibull distribution was utilized as it assigns a greater probability to more frequently or likely occurring value. The two-parameter Weibull PDF can be expressed as where X is the SPB cut and leaf treatment area plot size in acres, and the parameter scale and shape are estimated using Microsoft Excel solver. Parameter estimates of the two-parameter Weibull distribution were found by minimizing the difference between the observed number of spots by acre class and the predicted number of spots. Other PDFs tried were, for instance, the exponential, using maximum likelihood estimation. However, in our opinion, these parameter estimates did not provide a good depiction of the relationship between the number of spots by spot size acre classes. Therefore, we used the two-parameter Weibull distribution estimated using the least squares type estimator from Microsoft Solver. These are the parameter estimates using Microsoft Excel Solver, and you can see that compared to the exponential that you see in Figure 2, they substantially reduce the sums of squares error. The two-parameter Weibull distribution then allows us to obtain a cumulative distribution function that depicts the number of spots by spot size acres, as well as an associated PDF, probability distribution function. And from this, then, we can then estimate the probability associated with the acres of spots to allow us to develop a tool that managers can use to help infer about the cost associated with future outbreaks of SPB, both in the Bienville National Forest as well as other areas. And we can do this through the use of list sampling. So a user, based on the observations from the BNF in 2017, can then determine the probabilities of the acreages of spots and then assign some kind of spot treatment per acre, such as $645, to determine the probabilistic or value of treatment costs in a particular year for their, or any other specified time for their particular area. How would that work? So let's say there's a place that they expect to have 400 spots this year. Then, based on the CDF from the two-parameter Weibull, we can use list sampling, where we generate random numbers from 0 to 1, and then where that random number falls within the CDF categories, that acreage gets assigned to that spot. So if there's 400 spots, we can then say for each one of the spots generate a random number from 0 to 1, and whenever that number is 0.5327 or less, it's assigned a spot size of 2 acres. And if it's between 0.9705 and 0.9481, it's assigned a spot size of 18 acres, and we do this for all 400 spots, and then we multiply that by the treatment cost per acre, let's say $645, and we come up with a total estimate for an area in a specified time. An application was developed within Excel to provide users an easy way of determining a cost associated with an SPB outbreak.